everyone, in this video we're going to talk about graphing the sine curve and the cosine curve, the sine function and the cosine function. Now in a previous video we evaluated the trig functions of the quadrantal angles and we came up with these. We knew that the cosine of 0 was 1, the sine of 0 was 0, or the cosine of 2 pi was 1, the sine of 2 pi was 0, cosine of pi of 2 0, etc. So I'm going to take these guys, I'm just going to put it in this table here, alright? So the sine of 0 is 0, sine of pi of 2 1, sine of pi 0, sine of 2 pi of 2 is negative 1, cosine of 0 is 1, cosine of pi of 2 is 0, cosine of pi is negative 1, and the cosine of 3 pi over 2 is back to 0. And then this repeats, like a cycle, okay? Because you keep rotating this way or rotating this way, alright? It's periodic. And that's why when you look at these graphs, you can see I've already plotted the points here. At x equal to 0, sine is 0. At x equal to pi over 2, gets up to 1. X equal to pi, sine's back at 0. At x equal to 3 pi over 2, gets down to a negative 1. And x equal to 2 pi, it's back at 0. And notice cosine at x equal to 0, it started at 1, but it followed a similar pattern. And back at 2 pi, it's back at 1. So, we say that the period of y equal to sine x is 2 pi. The period is 2 pi. This is one cycle. And this is also one period of y equal to sine x. But we say the period is 2 pi. That's the length of one cycle. The amplitude is 1. That means this graph oscillates up 1 and down 1. Right there from the x-axis. Alright? Same with the cosine curve. The period is 2 pi. Amplitude is 1. It goes up 1 and down 1. So its range is from negative 1 to 1, but its domain is all real numbers. It goes from negative infinity to positive infinity. So if we wanted to graph more cycles, or more periods, remember this is one period, we could just take this. Let's see, we'll do y equal to sine of x here. Okay, starts here, goes up, down, back around, there's that one period, okay? Goes up to 1 and down to negative 1. But just repeat this. It's periodic. That's one cycle, that's one cycle, that's one period, that's one period. So we come back down here and go like that. Max 1, min negative 1. And if this was y equal to cosine of x, alright, notice it starts up here. Right here on the y-axis. Down, up. One period. One cycle. Do it again. This would just come down here, go down here, come back here, and up there. We can go on and on and on, okay? The domain is all reals. And if x was time, yeah, we'd say the period is 2 pi, alright? That's its time it takes to complete one cycle, alright, in application problems. So, knowing these, very important. So make sure you know these. You can always do it just from here. Alright, if you know these, you can make a table, put this out in no time. But these graphs can shift. Alright? But they can stretch or shrink. So we're going to talk about that. And we'll do a few sketches. So, up here, this value here, the coefficient, alright? Let's say it's some value like 2 or 3 or 5 or something like this. In this case, it's a 1. The amplitude will be the absolute value of that number. Alright? Pretty simple. The period of a function, if there's a value, a coefficient to this x, the period will always equal 2 pi divided by b. Alright? So we're going to do an example. We're going to sketch one period of y equal to 2 sine of 3x. And in all my examples, from now to the end of this video, we're always going to sketch one period of the function. Okay? So, x-axis, y-axis, y equals 2 sine 3x. So the amplitude is 2. That means it'll go up 2 and down 2. But this 3 right here, what it's doing, it's affecting the period. Alright? So let's go over here and calculate the period. The period for this graph, I'll just put PD, equals 2 pi divided by this number 3. Alright, and we're going to make a sketch of this, but we'll use this as a model. Alright, so here's what we'll do. See, we got 1, 2, 3, 4 tick marks. Let's do the same thing here. 1, 2, 3, 4. Tick, tock, tick, tock. Let's make 4 tick marks. Alright? Now, we can just sketch the sine curve. Sure. Goes up, comes down, halfway, comes down. You can do that first, or you can wait. How high does it get? Well, not 1 anymore. The amplitude is 2. So it gets up to 2, and it gets down to, let's see, right there, -2. But this is no longer 2 pi. Alright? This is no longer 2 pi. The period now is 2 pi over 3. So what we'll do is, let's go here first. We'll label this 2 pi over 3. Alright? Alright, it has a length of 2 pi over 3 to complete 1 cycle. So we got this tick mark here, this tick mark here, and this one. Well, this will be 1/4 of this length. So what we'll do here, take 1/4 and multiply it by the period. Yeah. What's 1/4 of 2 pi over 3? That's 2 pi over 12, everyone. And you're going to reduce that to pi over 6. Alright? For this one, well, this is halfway. So this will be 1/2 of 2 pi over 3. Put a dot in between these, and we're going to put that value. But we can break that. The 2's cancel. That's just pi over 3. So this is 1/4 of this, 1/2 of this. This right here will take 3/4 of 2 pi over 3. Alright, you get 6 over 12. 6 over 12 is 1/2, so 1/2 pi or pi over 2. Not too bad, huh? Here's another way too. Once you find this first tick mark, that means this is pi over 6. This would be 2 pi's over 6, pi over 3. This will be 3 pi's over 6, which is pi over 2. And this is 4 pi's over 6, which is 2 pi over 3. You can use that technique also. Alright? Now, here's our second graph. Let's graph this. How about y equal to -2 sine of 3x? Alright? What will happen? This graph will just reflect about the x-axis. Alright? So all I have to do is just take that out right there. Alright? Take this part right here. And this will reflect. So it went up like this, came down here. So now this graph will travel like this. Come here. It will reflect about the x-axis. And basically just flip over. Alright? There's that graph. Amplitude is still 2. See, the amplitude is always positive, the absolute value of that number. So you got -2, the absolute value of -2 is 2. Here, 2 pi. Alright? Let's do a few more. Let's do a cosine curve. Alright? How about y equal to 3 cosine of 2x. Alright, once again, tick, tock, tick, tock. Alright, what's the period? What's that amplitude? Amplitude is 3, so this graph will get up 3 notches. You can go 1, 2, 3, 1, 2, 3. It'll go up 3 and down 3. The period is 2 pi divided by that number right there. 2 pi divided by 2 is pi. So, this is pi. Alright, this time I'll do all the values first and then I'll sketch it. So this will be 1/4 of pi, and everyone 1/4 of pi is just pi over 4. This will be right here 1/2 of pi, pi over 2. This will be 3/4 times pi, pi over 4. And there's 4/4 of pi, which is pi. Now we'll sketch it. Start here? No, that's a sine curve. This is the cosine curve, so it starts up here, right? And it's going to finish up here for that 1 cycle. And just come down, whoop, whoop, whoop. It's a nice smooth curve. That's 1 period of y equal to 3 cosine 2x. Alright? A couple more. 2 more. How about y equal to the sine x plus pi over 2. So if you recall transformation of functions, all right, this graph's actually going to shift. All right, it's going to have a horizontal shift. So what we'll do is, everyone, what was the initial starting point of the cycle? 0. What's the initial ending point of this cycle? 2 pi. So what I'm going to do is take this x plus pi over 2. And let's set it equal to 0. I'm going to take this x plus pi over 2 and set it equal to 2 pi. I'm going to solve for x. This will tell me where the cycle starts and where the cycle ends. Alright? You can see where it shifts. Solve for x, subtract pi over 2 on both sides. X equals negative pi over 2. So that's where I'm going to start the cycle. Alright. Almost spelled cycle wrong there. That's where we're going to start the cycle. Now I'm just going to subtract this pi over 2 from both sides. Alright, I need a common denominator here. So it'd be 4 pi over 2 minus pi over 2. And everyone, we get 3 pi over 2. So this will be the end of the cycle. Or the end of one period. Alright? So, here we go. Shouldn't be too bad, but notice, it's going to start at negative pi over 2. They call it the phase shift. So the phase shift is negative pi over 2, where that cycle's starting. So it started about right here, negative pi over 2. But I'll put the tick marks down in a second, because we know it's going to end at 3 pi over 2. But how should we find these other ones? Alright? You know, where's the next tick mark? Is it here? Is it here? Where is it? So I'll put those down in a second. Okay? But notice the amplitude's going to be 1. Alright? And the period will remain 2 pi, because 2 pi divided by 1, that value right there, 2 pi divided by 1 is going to be 2 pi. So the period will be 2 pi from here to its end point, 3 pi over 2. Alright, so what I can do is this. Alright. I know it starts at negative pi over 2. I know it ends at 3 pi over 2. So, let's say for the next tick mark, alright, start, and we got this 1, 2, 3, 4, end. Well, we know it's going to start at negative pi over 2. And I'll put these values down here. And we know it's going to end at 3 pi over 2. Well, to get this value around, what we have to do is say, what's negative pi over 2 plus 1/4 of the period? That's what we're going to have to do to find that value. So negative pi over 2 plus 1/4 of the period 2 pi. And that's what that tick mark will be. This second tick mark right here, from the initial position of the cycle, will be negative pi over 2 plus 1/2 2 pi. This one will be negative pi over 2 plus 3/4 2 pi. So before, when I was doing 1/4 the period, 1/2 the period, very similar here, but I have to think about, you know, this is where the cycle started. So I take this and add it to it. So negative pi over 2 plus 2 pi over 4, which is pi over 2. Negative pi over 2 plus pi over 2 is 0. So I'll be the, boop, the next tick mark. How about this one? This is negative pi over 2 plus, well, these 2's cancel right here. So that'd be negative pi over 2 plus pi. And everyone, negative pi over 2, excuse me, plus pi would be negative pi over 2 plus 2 pi over 2, giving you pi over 2. The first one, second one. The third one's going to be negative pi over 2 plus this 3/4 2 pi, which is negative pi over 2 plus 6 over 4 is 3 pi over 2. And notice you get this, what? 2 pi over 2, which is pi. Yeah, a lot of math in there. You might find it easier just to say, oh, I see it's going by pi over 2's. So pi over 2 plus pi over 2, this will be pi. But that's what that is. And then this cycle is now going to end at 3 pi over 2. Okay, so it's going to start here. It's going to end here. It's the sine curve, so we have to draw this model starting here, all right, stopping here, and here goes the model. Whoop, 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 whoop. And notice this graph just shifted pi over 2 to the left, all right? Started here, the phase shift. And look closely. Isn't this the cosine curve? So now we know a trig identity. Sine of x plus pi over 2, that quantity is equal to cosine of x. Cool? Hey, one more. Let's do a vertical shift. All right. It's not too hard at all. But since we did sine there, we'll end this video with a cosine curve. All right, so let's do, how about y equal to cosine of x minus 2. So this minus 2 isn't in the parentheses or anything. There's cosine of x right there. You can think of it like this. Cosine of x minus 2. This graph just did a vertical shift. It's going to go down 2 notches. All right, the entire graph. So to start with, what we'll do is, all right, here's the x-axis with our tick, tock, our 4 tick marks. Notice the period is still going to be 2 pi over 1, which is 2 pi. Notice the amplitude is going to still be 1, but this is where the graph shifted. All right, so what we're going to do is, let's go down to -2. And I want you to think of this as the new axis that the graph is going to oscillate on. All right, almost like the axis of oscillation. All right, this is our new axis, such that the graph is going to oscillate from this -2 with an amplitude of 1. So it's going to go up 1 and down 1 from here. All right, so that's -2. It's going to get up to a -1. It'll get down to a -3. All right. The period is still 2 pi over 1, so this is still 2 pi. This is still 3 pi over 2. This is pi. This is pi over 2, just like before. All right, just like before. The only thing is, we have to draw the cosine curve. All right, it's going to oscillate on this new axis here. So do I start here? Well, hold up. Notice cosine started 1 notch above. So we're going to start up here. All right, I'll put this in blue. We'll start up here. It's going to end right up there, so right here. All right, we're going to go whoop. And then halfway between, it's going to get down to that -3 right there at pi. It's going to come back here. It's going to come back up here. All right, that's one period of the graph of y equal to cosine of x minus 2. All right, make sure to know these. You could build them easily from knowing this. Just make it a nice table like that, okay? And that's it.